Very good morning. Last week, we talked about one sample t-test. In that case, we were comparing the sample mean with the population mean. We had the continuous dependent variable, which was being compared with the population variable. So that was one sample mean. In today's class, we'll be talking about independent sample t-test. Here, we'll be having two different independent samples and just we'll be comparing that the mean of these two independent samples, are they significantly different from each other. So the independent sample t-test is used when the means of two independent groups are compared on a continuous dependent variable of interest. We can have an example here. A clinical psychologist wanted to investigate the relative effectiveness of cognitive behavioral therapy and psychoanalytic therapy on depression. 30 people suffering from depression were randomly assigned to receive one of the two therapies, with 15 people receiving cognitive behavioral therapy and 15 receiving psychoanalytic therapy. After 2 months of therapy, the depression score for each participant was recorded. The independent variable in the study is the type of therapy, that is, cognitive behavioral or psychoanalytic, and the dependent variable is the depression. With higher scores representing greater depression levels, the range of possible scores on depression scales is from 10 to 70. So that's the example. I again repeat. Here we have got a case of people having depression. And we are seeing that how the effectiveness of cognitive behavioral therapy and psychoanalytic therapy on depression is taking place. So two types of therapies we are using: cognitive behavioral therapy, which we can call as 1, and psychoanalytic therapy, which we can call as 2. So we have got sample of cognitive behavioral theory, that is 1, and psychoanalytic therapy, that is 2. Now we are trying to, you can say, see how these two therapies, which was used to treat 15 people each, um, how depression rate has, you can say, um, has gone down. And the depression rate we are, you can say, using is in a scale form, where we have, you can say, depression scale from 10 to 70. So that's there. Now coming to the objective of, you can say, independent sample t-test, here we are testing the means of two different groups, and we are trying to find out whether they are significantly different from each other or not. Data required for independent sample t-test is that we require two separate groups, and here in this case we have got the type of therapy we are using. One is cognitive behavioral, second is psychoanalytic, and we have the continuous dependent variable, that is the rate of depression we are having. So that's given to us. Now we have got, you can say, null and alternate hypothesis. Null hypothesis, we all know, which is saying that there is no significant difference between the mean of one independent sample with the other. So in this case, we are saying Hn, that is H null, or hypothesis for null, you can say, is that a mean of psychoanalytic is equal to mean of cognitive behavioral. That is, there is no significant difference between the mean depression rate of patients being treated through psychoanalytic, you can say, therapy or cognitive behavioral therapy. And if you look at the alternate, you can say, hypothesis, here we are talking of H2, you can call it, HA, you can call it, is that mu psychoanalytic is not equal to cognitive behavioral. This means that there is a significant difference between the mean level of depression in the people, you can say, who are being treated using psychoanalytic therapy or cognitive behavioral therapy. Now, one thing we know, that when we are evaluating the hypothesis, if the significant value comes to be, you can say, less than or equal to 0.05, we are accepting the alternate hypothesis. And in case the value of significance, which is denoted by p or small p, comes to, you can say, more than 0.05, in that context, we'll be simply accepting the null hypothesis. We've just seen the example here. The example is about, you can say, the depression people are having, and they are being treated through two, you can say, techniques. Two types of therapies are being used. We have number one, cognitive behavioral, and number two, this psychoanalytic. So we are using these two therapies, cognitive behavioral and psychoanalytic. And now we are, you can say, using these therapies. So the research question which we'll have is there a significant difference in the average depression level between those who received cognitive behavioral therapy and those who received psychoanalytic therapy? So we are saying, is there a significant in the average depression level between those who received cognitive behavioral therapy and those who received psychoanalytic therapy? So that is what the research question is. And then we have got the data. So I'll be just putting this data with me. So I'll be just copying this data. So I'm copying this data, and this is, I've just Control C, I've done, opened my, you can say, file here, gone to data view and clicked on here. So this is what I'm doing. Coming back to the, you can say, this file, I'm going for the therapy 2, Control C I've done, again gone back to my SPSS file, open that file, and here we are pasting data 2. So this is what we are having. So we have got the data, and now we'll be, you can say, using this data for analysis. So this is the data view where we have got first 15 respondents got, you can say, treated using cognitive therapy, and number 2 is psychoanalytic therapy for their depression they were having. So variable view which we are having. So we are having two variables. The first variable is therapy. So I'm just saying that type of or treatment of depression. So this is the name of the variable I'm saying, and I'm giving values. So sorry, values I'm to give. So I'm saying 1, and before I do that, let me see which is what. So we are having these, and sorry. So here we go. So we have these two therapies. Number 1 is there's a cognitive behavioral, and number 2 is psychoanalytic. So this is what we are having. So I'll be moving with that. So this is it, we are moving, and this is cognitive behavioral. Number 2 is psychoanalytic. This is one thing we've added. So I added the 2. Okay. And measure, we all know it is nominal. It is categorical variable where we have categorized it. So number 2 is depression. I'm saying, sorry, level I'm doing, level of depression. And here we have got values we are not to mention because level of depression is from 10 to 70. And that is itself saying that this is the level of depression, 10, 15, 20, 25, that level itself speaks, and there is no need for the value to be done. It is more of in scale form. So this data is in scale form, this we have done. Now, if you go to data view, this is what and how the things are. So there's it. This is how the data is appearing here. Now, this data is actually appearing, you can say, as cognitive behavioral and psychoanalytic because it is a numerical theory. There can be instances when your data will appear like this. Now, how to take care of this data when it appears like this? What you simply do is you go to view, go to value labels, and it will be appearing, you can say, as you have coded it in the, you can say in the actual, you can say, values of the variable view. So that's all. And now we'll be going for one sample, you can say, sorry, independent sample t-test. So going for the test, we are going for analyze, we are going for compare means, we are going for independent sample t-test. So we're clicking on this, here we go. So first of all, we are going for type of therapy used. Now this will go to grouping variable and we have to define the group. One is for the cognitive, number two is for the psychoanalytic. So that is here. I'll do continue. Level of depression is the test variable or the independent variable which we are using. And here we are. Now, as far as options are concerned, so 95 is the confidence, you can say, interval percentage. We'll continue with that. And then I'm simply, you can say, going for okay. And as soon as I do it, I get the answer. What I do is I take you to the new share of the output file for you to see the output file. Here we are. We are now seeing the output file where we have got the level of depression, cognitive behavioral, we have taken 15 people. Psychoanalytic, we have again taken 15 people. Mean for, you can say, cognitive behavioral is 55.933, whereas for psychoanalytic, it is 45.000. Standard deviation is 9 for cognitive behavioral, it's 7 something for psychoanalytic. So that's there. So that is we know that people, you can say, who were being treated with cognitive behavioral, you can say, level, their you can say depression level appears to be high, at least by 10 points, as compared to, you can say, psychoanalytic, you can say, a treatment that was being given to the remaining, you can say, uh, people suffering from depression. Now, if I'm to, you can say, use this test, what I'm going for is that I'm trying to see that there is something called standard deviation. The standard deviation is 9.5 for cognitive behavioral, but is 7.6 for psychoanalytic. And this standard deviation is very important for me because I want to see whether the standard deviation is similar or is it quite varied. And this can be tested when we are talking of, you can say, the number 2 table, where we are talking of Levin's test of equality of variances. Here we are talking of Levin's test of for equality of variance. Now, if you look here, the significance come to 0.555. This means that the difference in the variance, standard deviation and variance is the same thing. Standard deviation, when you can say squared, becomes variance. So the difference in the variance is not much, or you can say it is within the permissible limits, because had this value of, you can, significance being 0.05 or less, if this value here would have been 0.05 or less, we would have taken the second row. Since this value is, you can say, more than 0.05, we have taken the first row. So it is just to, you can say, if I'm talking of this Levin's test of equality of variance, it is just to confirm which row of, you can say, t value you will be considering, the below, the bottom one or the top one. So if the value is 0.05 or less than that of Levin's test, we'll be taking the bottom, you can say, a row. In case it is more than that, it is 0.05 above 0.05, we'll be taking the top row. The case being the same here, we'll be taking the top row, which says that t value comes to, you can say, 3.473. Degree of freedom is 28. Why? Because n minus 2. So we have got n is n minus 2. So n is 30. And why I'm saying 2, it is basically n minus k. K is 2. So 30 minus 2 is 28. And significance comes to 0.0002. So it's almost, you can say, 99.8% significance. That is what is, sorry, I'm not saying significant. It should be the confidence interval level is 98.8%. So this means there's a significant difference in the depression level of people who are, you can say, being treated, you can say, through cognitive behavioral treatment as compared to one who are being treated using psychoanalytic. So that's being the case. I'll try to, you can say, work up on this particular, you can say, test again, just to help you understand that how we are conducting these tests. So we are going for analyze first. We are going for compare means. We are going for independent sample t-test. And what I'll do is I'll just reset it. So maybe you can say next time when we are using it, so you have the things coming up. So analyze we are going, compare means we are going to independent sample t-test, and this is how the things will open for us. Now you have got one, you can say, variable which is in what do you call it, a nominal form, which is an independent variable to be placed in grouping, you can say, grouping here, and we have to define the things. Now we know that we have placed cognitive behavioral as 1, so it will be group 1. We have placed psychoanalytic as 2, so it will be 2, and we'll simply say continue. Similarly, level of depression will be a test variable, and we are just looking the option. We need not look at the option, but I'm just telling you it is confidence interval percentage is 95. I told you significance level of 5% or 0.05 is equal to confidence interval percentage of 95%. So that being the case, so this is something which we'll be assuming and keeping the same. So I'll click on continue, and here I'll click on OK, and then I'll get my responses. These responses we've already seen. Level of depression for cognitive behavioral for 15 respondent is 55.933 with a standard deviation of 9.5 something, whereas for psychoanalytic, again for 15 respondents, it is 45, exactly 45 with a standard deviation of 7.6 something. This is one thing. This one thing we know is that there is some difference in the depression level of, you can say, people who got treated using, you can say, cognitive behavioral as compared to one who got treated through, you can say, psychoanalytic type or method. And then coming to the standard deviation, the standard deviation of the two is, you can say, again a bit different. Now we have to first look at the standard deviation, and here if you look at the second table, we have got something called the Levin's test of equality of variance. We have got Levin's test of equality of variance. When we have got that, this test is being conducted to simply see whether the variance and standard deviation is, when you square the standard deviation, you get the variance. So standard deviation, or you can say, you can call variance right now. So variance, is the variance significantly different or not? If the variance is significantly different, the significance will be 0.05 or less than that. If this variance is significantly different, it will be 0.05 or less than that, and we'll be taking row 2 for the value of t and significance. Here in our case, the value of significance is more than 0.05. It is exactly 0.555. This means that we have to consider row 1 here. I suppose we got the point. This is very important for us to know that whether we are going for row 2 or row 1 to actually see the value of t. Here, the example, you can say, suggesting the same value for t for both the rows, but then the value of t will differ. Maybe you can say when we do some of the examples. Done. So just coming to the question back, when we see the mean, we see that the mean is different and quite different, because a difference of 10, at least 10, is something you can say apparently big here. With the scale of, you can say, moving from 10 to 70, a difference of 10 is a big thing. And second thing, if you look at the value of t, the value of t, you can say in the first row comes to 3.473. And just remember one thing, by default, if the value of t is more than 2, it got to be significant. If value of t is 2 or more than 2, it got to be significant. Here the value of t is 3.473 with a significance of 0.002. So we are accepting the alternate hypothesis. So that all about you can say the test and all from the output file. Moving back to our you can say this example set. So we have done this example. We have talked about this example. We have done the test also, and now we'll be, you can say, moving ahead. So these are the assumptions we are, you can say, using when we are conducting one sample t-test, sorry, independent sample t-test. The observations are independent. The independent variable is normally distributed for each type of the group in the population, and the variances of each of the groups are equal in the population. So these 3 points we have to remember. I want you all to go through, you can say, the assumptions, the observations are independent. So when we are talking about psychoanalytic and we are talking about, you can say, cognitive, you can say, therapies, they are two independent therapies, and dependent variable is normally distributed, and the variances of each of the groups are equal in population. So variances are same, and therefore we are doing the Levin's test. So that is about 1, 2, 3 point. Now coming to, you can say, the steps we are going to take when we are conducting, you can say, the independent sample t-test. Those steps we've already, you can see, seen in the actual example we just conducted, and we all know that we are interpreting the results. We have to see two things. First of all, we have to look at the mean and then the standard deviation in table 1. In table 2, we have to look at the Levin's value. If Levin's value significance there is less than 0.05 or even equal to 0.05, we have to consider row 2. Otherwise, we have to consider row 1. In that case, in the example we did right now, we were considering row 1 only. Now coming to the, you can say, the actual, you can say, p-value or significance value for the t-test was is again to be seen the same way, where if the value of you can significance is 0.05 or less than that, we are in, we are accepting the null alternate hypothesis. We are accepting the alternate hypothesis, and we all know if the value of significance is 0.0 more than 0.05, we'll be accepting the null hypothesis. One more thing, and that's very important, we are talking about the effect size. What is the effect size of this test, whether it's a small or large, medium or large? So that we have to see small, medium or large, what is the effect size? And for that we have got D value to be calculated. The same thing we did during, you can say, our study for one sample t-test also. Here calculating, you can say, D is a bit different. D is equal to T value, that is to be multiplied with under root, and in the numerator we have got n1 plus n2, and in numerator we have got n1 into n2. So T value we know is 3.514, so that T value is already known to us, and the value of, you can say, n1 and n2 is again known to us, 15 plus 15, so that's 30 upon 15 to 15, 225. So 30 divided by 225, under root of that multiplied by 3.514, and the answer is 1.28. And we know one thing, if the D value, you can say, is 0.2, it is small effect size. If it is nearly, you can say, 0.5, it is medium effect size or average effect size, and if it is, you can say, more than 0.8, it is a large effect size. In our case, the value of D is 1.28, which means the effect size is quite large. So that's there. And how to write this result? You simply look at the answer and you will find it. Look at the lines I've quoted here to write the answer, and you can use this to actually, you can say, as a sample or as a template to, you can say, quote your own answers. Now, those who received cognitive behavioral therapy, M is equal to 45, standard deviation 7.63, had significantly lower depression scores than those who received psychoanalytic therapy. M is equal to 56, standard deviation of 9.42. And T value at 28 is equal to 3.51 with significance, you can say, less than 0.05, at D value of 1.28. So that's there, and we have done this question. I would request you all to, you can say, revise the question, do it again and again, and definitely, you can say, you will be better prepared to, you can say, do these questions easily in future. Thank you then. Thank you.